Hi, good morning. It's Jim from the maverickstar Observatory. Guys, in this video we're going to have a look at some of the evidence, the proven evidence of the changes that are taking place right now on our planet and in our solar system. Before we do, as usual, big thanks to those few people. And you know, I always say this and people always say, oh, well, you always say few people, because trust me guys, with the small number of patrons we have and the exception of a few can count, there isn't very many people right now supporting the observatory, and it's not really fair to leave it in the hands of just a small amount of people when we do have on this channel 30,000 subscribers, and every day if I put a video up we reach over 1,000 views. And you know, it's a clear indication that more people could actually do a little bit more to help. And you know, at a time like we're experiencing right now, you know, help couldn't be any more needed, guys. So there is a link down there if you want to help support us. So let's get into the chart, what we're looking at, the space environment overview. And yeah, I know it's from 2014, but that's perfect for us because it tells us what was going on during the last solar maximum at 2014. And today we're going to focus on some evidence of changes, and we can make some predictions as to what to expect from that evidence that we're looking at. So let's start with the top section of this chart. You can see the troughs in between each solar cycle, and one thing you'll note is that from solar cycle 21 to 22 the trough is very narrow. The two solar maximums of each solar cycle are very close to each other, but from 1980 to 2001, you'll see that the gap in between the troughs in between the solar cycles is widening out. So something is changing. Now, on average, we know that the sun goes through a solar maximum on around about, on average, every 11 years. And from 1990 to 2001 is a clear, perfect example. From solar cycle 22 to 23 is 11-year interval. But from solar cycle 23 to 24, things change dramatically. First of all, the trough is getting shallower, so it's not as high in the peaks of the solar cycles at solar maximum, and the trough is being spread out further apart. From 2001 to 2014 is 13 years. So the cycle was longer, and the actual amount of sunspots during solar cycle 24 was a lot less. If we just drop down to the cosmic ray part of this chart, you'll see also something changing with the amount of cosmic rays, which is a clear indication that cosmic rays are on the increase as we get weaker and weaker solar cycles. So starting at the trough between solar cycle 21 and 22, we can see the band that crosses the line of cosmic rays. It's just a narrow peak, but if we move on to the next cycle, we can see that the band is widening out and is becoming more increased in height. So what's happening is from solar cycle 22 we are receiving more cosmic rays in our upper atmosphere, which are having an effect on the upper atmosphere, colliding with those particles, smashing into them, creating smaller particles, elementary particles that come through. And you know, in some cases, some of these particles go straight through the Earth. Some of them, you know, before they even get to the Earth, they disappear or decay. But when we get to solar cycle 24 and have a look at the amount of cosmic rays, we can see that it's almost doubled, if not tripled. Now, it is a bit disappointing that we can't get a space environment overview to the current time and date. If we could, what we would be looking at is something completely shocking, guys, because the level of cosmic rays right now in our solar system and in interacting with our magnetosphere at this moment would be 4 times that or 5 times that of what we were looking at in between the cycles of 23 and 24. This is clear evidence that, as time goes on from this point and we don't see an equilibrium, and what I mean by that is we haven't reached a halfway point where we've started to see sunspots increase again to good healthy numbers, and that would be an indication that also the heliosphere was pushing out past our solar system, offering us a lot more protection from galactic cosmic rays. So we do know from looking at charts like this a lot of information, and we know that from the amount of cosmic rays that are on the increase, so forth are the risks to all the biodiversity on this planet. And this is just with relationship to our sun and how much protection we get from that. Another fact is that our Earth is experiencing a magnetic reversal, and has been doing so since the 1900s, when it left Canada and started to track over the northern hemisphere. This adds to the same problems that we experience when the sun goes through a grand solar minimum, in the fact that really one thing that directly affects us is the interaction in our upper atmosphere and the production of smaller elementary particles affecting the jet streams. You've probably come across the term cloud seeding, and these small particles attract ions and they grow in size until they form a platform large enough for precipitation and condensation first of all to form on them, and then when they become abundant in the atmosphere they precipitate. We're seeing the effects of this precipitation destroy crops around our entire world, and it's unpredictable. What we do also notice is the bandwidth of the jet stream, and another two problems with the jet streams that create large scale damage. We see first of all the mixing of the two jet streams, so there is a subtropical and a polar jet stream now merged to one. Later on I'll show you that, and as a result of that we end up with super jet streams flowing round our Earth at somewhere in between the two latitudes of the polar jet stream. So somewhere in between 60 degrees and 30 degrees is where now we have this super jet stream forming on the northern hemisphere and on the southern hemisphere, as I've pointed out before in other videos. So a couple of the things that we've noticed in between these two lines that you can see now is almost a corridor of where the magnetic North Pole has been tracking for at least the last 120 years, and it's directly moving towards a location somewhere central of Russia. And the reason why it's doing that is because the magnetic intensity over Russia right now is getting stronger and stronger, and therefore stealing the magnetic North Pole away from Canada. And at the same time, Canada's high intensity is weakening and weakening, and as a result it can no longer hold the dipole over the northern hemisphere in that location. So we know by studying the intensity strengths where the poles are going and why they are migrating in the first place. We don't know so much about the mechanics that drive the dynamo inside the Earth. It is still all theoretical, but maybe one day we will have a clearer picture. Maybe through studying this rare anomaly that's taking place right now, we will unpick the secrets of the inner Earth and find out how our Earth generates a magnetosphere, and in turn its poles, and why they reverse. So just taking a look at the jet streams today, if we look over the southern hemisphere, that is a perfect example of a super jet stream. Its width is probably well over 1,000 miles long, and you can see if I just bring it round a little bit, there is the interaction with the subtropical weather mixing and being delivered in the trough of the jet stream down into the polar regions. This is going to increase snowfall over the southern hemisphere and over the Antarctic, and it's also going to change very very much the dynamics over the southern hemisphere. Now, right now, what you've got to remember is, the southern hemisphere is in the winter. With regards to the rotational axis and the slight tilt that we're at, and the position with regards to the sun, it puts the Antarctic region just slightly further away from the sun at this point in time of the year. However, on the other hand, if we have a look over the northern hemisphere, what we'll see, as we are, with regards to the advantage of the tilt, putting us in a very, in a similar direction. Sorry, not direction. What's the word I'm looking for? Position to the sun. We are in the summer, and as a reason for that, you can see there's a very different story being told with the jet streams. Lots of fragmentation, no clear polar jet stream, and no clear subtropical jet stream. And we are going to get, when we look at jet streams like this that are fragmented like that, we are going to get sporadic weather patterns. So when it starts to deliver on the one hand, from the polar jet stream to the subtropical, we're going to get a lot of rain. And when we get the jet stream going up over towards the northern hemisphere further and into the Antarctic region, it's going to convert that into snow. But the big point is here, only around about 30 years ago, and we've had pilots, say the same thing. We used to get, like, before we got on the flight, a map of what the jet streams was going to do. And obviously, why pilots want to be in the jet stream when they're travelling, because they can arrive at destinations. If they've got a tailwind, they can get there quicker, use less fuel, etc. Or if they've got a headwind, it's going to slow the journey down. So it's important for pilots to know from day to day what is going on with the jet streams. And it's very difficult now for them to predict, with weather charts on the morning before they get on board the plane. If it's a long haul flight, it's very difficult for them to predict, that it is going to be remaining in that direction for them to benefit from using it. When you look at the fragmentation over the northern hemisphere of our Earth, it really does look quite shocking. There's a lot of fragmentation. There is no pattern over the northern hemisphere around 30 degrees. There is no pattern of the subtropical jet stream around 60 degrees. And as a result of that, this is why, we're losing crops. This is an example of why, good arable cropping land is going offline, because seasons are no longer predictable. And as things get worse, guys, like I say, we're not in the equilibrium part yet. But as they get worse, it's going to be a lot more harder for farmers to predict, whether they're going to be able to get that crop in the ground and get it out, as they have been accustomed to enjoying in the years gone by. What that will mean for us, the 7 billion souls on this planet, it will mean that, food is going to become more scarce. Now, on top of that, at this point in time, nothing could be any worse, could it? Not only are we suffering now, the looming of an economic crash, and the effects caused by this COVID-19, and the effects that has had on the food industries as well as other industries. We are also facing the nature of our planet and our solar system changing as well. And at the same time as that, we are going through one of the rarest anomalies known to mankind on this planet right now. On this time, as you're hearing me, these changes that take place very, very slowly, do mount up over a long period of time. And as a result, we are now starting to see just some of the implications that we are going to face as a result of that. We haven't even mentioned one of the other possibilities that could really wreak havoc on this planet. As we experience, a continued weakening magnetosphere, it's not just cosmic rays that puts us at risk. It's one of those other things. A coronal mass ejection, a CME, coming off the sun at a point in time where our magnetosphere is weakened, and that in turn could crash the grids around the world and damage the electronic infrastructure of our planet. That is a real risk that we face during a time of magnetic pole reversal on this planet. So guys, a different approach today with the video. I just wanted to bring out a few facts, mention them to you. I'm going to mention the link down there, guys. Please get behind our observatory, help support it. There is a lot worse things, guys, that you can do with your money than support an observatory. Trust me out there. But it would be great if a few more of you would take our observatory under your wing and help us and support us keep going and doing what we do. We've got some great things coming up over the next few weeks. We're going to be getting some data back off one of our muon detectors down in Perth. On the 17th, we're going to be pulling the Trimag and the magnetosphere SD cards out, processing that data, adding it to the website. And as you guys know, there is always a stream of data coming in from somewhere or other now around the world due to the fact that we've got all this equipment out there. And as a result of that, we put it up on the website so you get to see firsthand. And the unique thing about that is you're not getting that information anywhere else. And I will say this, we've probably released to this point in this year more information, more important information to you guys than any of the mainstream organisations. Just to mention two, the European Space Agency and NASA. And that's why it's worth supporting. So there's a link down there. I'm going to say nothing more, guys, than, be safe, look after your loved ones, and I will see you at some other point in time. As always, bye for now.